In this video, I'm going to show you how to find limits as x approaches infinity. So when x approaches infinity, this is a little bit different because we can't just plug infinity into our equation here that we're given. So what we need to do is divide everything by the biggest exponent in the base of, or in the denominator, okay? And when I mean the biggest exponent, that doesn't mean by 2, that just means it's like we're basically dividing by 1 in the form of the biggest power in the denominator, and this is what that looks like. So the biggest power we have in the denominator, we need to divide. Biggest power we have is this x squared, so we're going to divide by x squared over x squared here. And when we do that, this is a little less complicated than it may seem. We just divide every term by x squared, okay? So this first one, when we divide by x squared, we just get 5. Divide here, we get plus 2 over x. Okay. I realize I have a mistake here. I maybe should have 3x, but that's okay. We'll just go with this. Maybe we'll have 1 over x and then minus 12 over x squared on the top. On the bottom, we're going to have 1 minus 7 over x plus 3 over x squared. Now we can plug infinity into this whole thing. And what happens is if you plug infinity into the bottom of a fraction, so say into 2x, okay, that number is going to get really tiny and get really close to 0. Okay, so think about this. If we think about it in terms of like bigger fractions we're used to, like 1/2, 1/3, 1/4, 1/5, each of these each of these fractions gets smaller and smaller and smaller. So if you had like 1 over 100, that would be even tinier. So if we plug infinity in, that's basically like saying, okay, that goes to 0. So we call this poofing. So this poof to 0, poof to 0. X squared, well, infinity still, right? So poof to 0, poof to 0, poof to 0. So what we end up with here then is 5. And that is our limit as x approaches infinity for this problem. Let's look at another one. Same deal here. We're dividing by x squared again, it looks like, over x squared. Okay, first one, 1 plus 3 over x minus 2 over x squared. On the bottom, we have 1 over x squared minus 1. Poof, poof, poof. Negative 1 is our answer for this one. Because we have this, that's a negative there. This one, biggest one on the bottom, is just x this time, so we're going to divide by x over x. The first thing we have is 3x minus 4 plus 9 over x. We have 2 minus 1 over x. Poof, poof. Okay, so we're left with 3x minus 4 over 2. Now what are we left with? Well, we could plug infinity to this. So we end up with, well, 3 times infinity is infinity, minus 4. Well, that's still kind of infinity, right? It's still really big. Divide that by 2, it's still really infinity. So our limit, they're saying, is infinity here. And that means that the limit does not exist. Okay, so if you end up with infinity for an answer like this, does not exist, would be what you would have to say. Okay, now this one, we can't just plug infinity in because we'd be multiplying stuff weird. So what we need to do first is FOIL, or distribute, I suppose would be the technical term for this. So we have 6x squared outside 8x inside 3x, so plus 11x plus 4 on top. On the bottom, 6x squared minus 30x. Biggest power on the bottom is an x squared. Divide by x squared over x squared. 6 plus 11 over x plus 4 over x squared over 6 minus 30 over x. Poof, poof, poof. We're left with 6 over 6, which is 1. So that is how you find the limits as x approaches infinity.